Hello, everyone. It's really nice to see you again. Today, as usual, we are going to talk about a technology topic. And we are having as a speaker Adrian Mena. He's a rockstar developer in our company. So, no more words, and let's start with our topic.
Hello, guys. Welcome, everyone. Welcome to this Lunch and Learn opportunity. I'm really glad, really thankful to be here with you today. So let's get started. Let's get started with our topic. Today, we're going to talk about data wrangling in Python. This is a really interesting topic, something I learned recently, actually, and that I think it's really amazing to get to know a lot of stuff about data science, actually, which is part of what we're going to talk about in this data wrangling topic. So let's get started. We have a problem that we're gonna think about today. And the thing is that data is everywhere. Data is everywhere. Data is found in different kinds of formats, different sources, and we can gather data in different kinds of ways. So we know that we have a lot of data. In our world today, we have different places where we can gather data. But the thing is, how do we process it? How do we get information from data? And the thing is that data does not always mean information. If we see this graph here today, we have that data are facts. Data is something we know about the world. But information is something that lets us transform this data into knowledge, into decisions, into insights for example, our companies, for business decisions, or for mostly science, for getting to know more about our world. And this is where data science helps us. It helps us unlock information from raw data to answer questions. So this is the problem that data wrangling and data science try to handle in our world. So this is really interesting because we have a lot of data. We have data gathered from our devices. Today we have a lot of wearables and personal devices that are always getting data of our position, things we do, things that are interests, and all this information is really helpful for companies. For example, think about Facebook. When you get something is addressed to you, and you go into Facebook and you see an advertising about shoes, and you were just talking about shoes, and you think it's just like magic. But the thing is that there's where data science and data wrangling comes into, and it's because all your data might be being analyzed, or everything that is on the network, on the internet, can be analyzed. And that's what we're going to talk about today. So what is data wrangling? The thing is that this is a process about gathering, selecting, and transforming data in order to be able to analyze it, to transform it into something useful. So first, we have to gather data. We have many sources. We can gather data from our devices. We can gather data even going with a notepad and writing stuff about what we see. So we have spreadsheets. We have CSV files that we can have as data sets. And that's what we have nowadays in the world. We have a lot of data. Now we have to do something with it. And we have to select the data that is important for us. That's the main goal here in this part. And it's that we have a lot of data, but not all of data is useful. So we have to select the useful data. We have to clean the data that we have in order to make it something we can analyze. And we have to transform the data in order to make it standardized for us. So for example, we're going to see an example today, but work. So if you measure temperature, for example, in the US, you most likely use Fahrenheit degrees. But for us in Latin America, that most of the time doesn't really make sense for us. So we have to convert to transform it to Celsius degrees. So this is what we can do into this process of data wrangling. Now we're gonna see today a really interesting tool. If you haven't seen about it, if you haven't heard about it, I encourage you to go and find about Jupyter. This is a really useful tool for Python development, for Python scripting, where you can do this. We have an empty file, Markdown syntax, where we can write a file like a document, like a Word document. And inside it, we can have Python code to execute it. So this is really useful. I encourage you to go and see about it. And it's really fun to use, actually. So now we have Jupyter. We're going to be using this tool today. And we have Python data science packages. This is the other tool we're going to be using. And the thing is that data science in Python is one of the most used tools, because we have a lot of libraries and a lot of stuff that we can use and that is already built. So we have some data science packages. For example, we have three main groups: scientific computing libraries, as pandas, numpy, and scipy, which are functions and methods that we can use that handle data structures. For example, with pandas, we have something called data frames that we're going to be using today. We have numpy with arrays and matrices for executing operations over them. And we have scipy for more advanced math problems and math functions to be executed. So these are three really useful libraries for scientific computing. We also have visualization libraries as Matplotlib and Seaborn, both used for plots and graphs, which when you're analyzing data, most of the time you're going to find interesting stuff when you see a graph more than when you see just numbers. So that's what this is useful for. And we have algorithmic libraries, mostly used for machine learning tasks and modeling tasks, as scikit-learn and stat models. Scikit-learn is really useful for building regression models, classification models, mostly mathematical stuff, but inside the field of machine learning. So go and see about it. This is really interesting. Both of these libraries lets us explore data, build models, and build tests for our models. So this is really fun. So today we're going to be working mostly in the field of data wrangling, where we can see and clean our data. And then after that, we're going to work with the modeling. That's not something we're going to be doing today, the modeling part. But the first part, that is cleaning and transforming the data, which is really important to build a successful model, that's what we're going to see today. So let's get started with our model, with our demo today. We're going to be checking some concepts aside of working on a demo. So let's import some data. We have some ways to import data sets. We can have files, for example, in most sites that give you a lot of information, a lot of data in form of data sets. Most of them use CSV files or JSON files. We can gather this from APIs, public APIs, for example, Excel files, HTML files, or even SQL exports. So we can, first, we're going to execute this. We're going to import our libraries, pandas, and numpy. Here you see we can execute Python code here. And we're going to read some data. We have a data file here called auto.csv that has a lot of data here for cars. The example we're going to be using today is cars data. So this cars data mostly have the goal of predicting prices. And yeah, I'm getting your comment. So we have prices that we want to predict according to all the information we have about a car. So Hello. So we have some methods that we can use to work with data here. We have this head data method that lets us see and shows us the first 5 rows in a data frame. So we're seeing here the first rows from our data frame, and we can also do something as see the last 10 rows of the data frame with this tail function. Those are really useful functions. Now we want to do something. We want to see our information with some headers. So these headers are going to be used for knowing what we're seeing here. So we have normalized losses, make, fuel, aspiration, body style, drive wheels, engine location, and some information about a car that are going to let us predict a price. That's the final goal. So we can set the headers to the columns of our data frame, which we said is a form that Pandas uses for handling data. It's like a virtual table for organizing data. So this is the way we can import some data. Now it's time to pre-process it. We're going to do something with this data to clean it and to work with it. So we have to do cleaning, some cleaning. We have to deal with it. We have to identify missing data. We have to convert empty values. Sometimes we have empty things in our data set. For example, we don't know the make, or we don't know the type of engine that a car has, but we have all the other information. So here's when this cleaning is important, because this is something that a computer most likely won't be able to do. We have to think about different ways to clean this data. So first of all, we need to identify missing data. In order to identify missing data, we're going to do this. We have, for example, here, Pandas opens the file and imports it, and when it doesn't find anything for a column, it just sets it with a quotation mark. So, sorry, a question mark. So then, for cleaning the data, we need to do this. We need to replace the question mark with an object into Pandas library that's called NaN. Most of you should have seen this in any programming language, and it means not a number. So it's something that we don't really have. So we're going to replace it with this function, really easy. Replace this symbol with not a number object. And the in place means that we're going to do it inside the same data frame. Because if we don't put this, the original data frame is not going to be affected, and it's going to return something to a new object. So we want to do it in place now into the same data frame. So we can execute this, replace, and we have this information. We have replaced every question mark with not a number. So this is the first step, identify missing data. Now we have identified missing data in our data set. We can deal with missing data. Now we have some different strategies here, and most used are dropping information or replacing information. This is where we need to think as data analysts or data scientists, and we have some methods to do this. So we have is null and not null methods here in the data frame, and we can see how many missing data we have here. So this method gives us a new data frame with true for everything that complies this, and this is null. So true for every null value or not a number value, and false for every valid value. And now we can print inside a for loop. For each column, we're going to see the values and count how many missing values we have. So for example, for symbol in column, we have 205 false values, so everything is okay. But for normalized losses, for example, we have 41 true values. That means that these values are null or not a number. So we can't use this. We need to do something with this column in order to have clean data. We have for every column this value. Number of doors, for example, we have 2 missing values. For what else, everything is okay here. For the bore, which is for anyone that knows about mechanics, I just learned about it. So it's something in the engine. It's a specific parameter in the engine that means it's going to be more powerful or not. So bore and stroke are parameters in the engine. And we have 4 missing values for each of them. 2 missing values for horsepower, 2 for peak RPM, and 4 for the price. So we need to do something with these missing values. We have 3 different strategies that we are going to analyze today. One of them is replacing by the mean. So we have, for example, 41 missing data, missing items for normalized losses. So if we want to replace them for sometimes the information is not in the correct format. Sometimes Pandas misses something and doesn't set an object to float and just as a string. So we need to set this in order to calculate our average. How do we calculate our average? Just this. We have the mean function here. And we can print it, and we can replace the not a number objects with average normalized losses. So this sets every missing value to 122. Same for the other stroke, bore, horsepower, and peak RPM objects or columns. Now we have one example as number of doors. We can't actually replace missing values of doors with, I don't know, the mean of the doors. Most likely the mean of this column is going to be something like 2.5 or 2.75 doors. And we can have that number of doors in a car, right? So we can replace it with the most frequent value, which in this case is 4. How do we see that? We can count the values that number of doors has and get the max for it. So if we get that, we can get that 4 is the most frequent value for number of doors. In this case, 84% of sedans are 4 doors. So this is an insight that we already have. And let's us think about this. So we're going to just replace the not a numbers for our most frequent value, which is 4, right? So this is interesting. We now have 4 missing values for price column. What are we going to do if we don't have the value for price and our goal is to predict the price of a car? If we don't have this, it just doesn't matter to us. So that car is not going to be useful for us to predict or to build a model. So if that's what we want to predict and we don't have it, just drop that car from our data set. That's not useful for us. We have this method called drop now, and we send the price. So that lets us drop every row that doesn't have a price, a valid value for the price column. Now we reset the index. Why? Because we're dropping something from our virtual table, and our index is going to be modified because we don't have 205 values anymore. We have 200, and in this case, we deleted 4, so we have 201, right? That's important for us to reset the index. Now, we need to correct data format. This is what we were talking about: integers, float, text, other kinds of formats. we can have them in our data set, and we need to handle this properly. If we try to calculate the mean of strings, this is going to just blow up. So we need to put the right format on each column. That's what we're going to do now. And we have, for example, dtype and asType methods here. Dtype lets us see which type of format we have for each column. So for example, here, we have the price is an object. In Pandas, object means it just found a string or something like that. So we don't need to have price as a string or as an object. We need to have price, for example, as a floating number, right? A float point number, as a decimal number. So we're going to set the proper types for each column. For example, bore and stroke needs to be float. Normalized losses could be an int. Price should be a float. Peak RPM should be a float, which doesn't happen now. So we're going to execute this. And now if we bring the data types, we have that, for example, price is now a float number. So now that we have clean data, which we deleted missing values, we have proper set up our data formats. We can do something. We can transform data. And we have 3 different strategies to transform data. First one is standardization, normalization, and binning. Standardization means we want to have a common format for a meaningful comparison. What's that? For example, we have a couple columns in our data set that is city miles per gallon and highway miles per gallon. So we want to standardize this to be used in an application in a country like Ecuador or Colombia, here in Latin America, that we mostly use. We don't use miles per gallon to calculate the efficiency of a car, right? We use maybe liters per 100 kilometers, an example. So the formula for this conversion is just divide 235 over the value in miles per gallon. This is really easy with Pandas. We just set 235 divided by the column called city miles per gallon. We print it now. We have a new column here that's called city over for the liters over 100 for each 100 kilometers, right? So we have something that makes more sense for us, that we don't really use miles per gallon as a unit of measurement, right? This is part of the standardization process. Same for highway miles per gallon. And we have both new columns. What now? We can do something called normalization. This normalization is transforming to a similar range. This is an example, but if we want to compare measurements like length, width, and height, we can transform this or normalize them to be within a range from 0 to 1. So the height of a car is not going to be 2 meters, for example, but it's going to be now, if that's the maximum value in our data set, if that's going to be 1. If we have a car with 1 as height value, that's going to be 0.5, right? So we want to divide the value by the column's max value. Really easy in Pandas. Just divide the name of the column over the maximum value of that column, right? We're going to do that for length, width, and height. And what we see now is this. This is interesting syntax here for Pandas. We can select the columns we want to see like this, in between brackets, right? So here we have that, for example, the first 5 cars, height is around 0.8 and 0.9. So there must be a car somewhere in our data set that has a 1 here for height. And that's the most tall, let's say, car in our data set. So this lets us compare something, because we don't use now measurement units like meters or feet. We just have a value between 0 and 1. This is useful most of the time for these kinds of values when we are going to build a model in the future. So, and we have the last strategy, which is binning. This binning lets us do this, which is really important for us. Continuous numerical values to discrete categorical values. What does this mean? What are continuous numerical values? These are values that, for example, I have we're going to use horsepower for our example today. So for example, horsepower is a real valued variable from 48 to 288. And we have 57 unique values. But we could have decimals, for example, where we have an option to have infinite number of values, of different values here. And that is really difficult to plot, really difficult to analyze. So what can we do? We can bin them, group them in different bins. We're going to rearrange these values into 3 bins today, as an example, to simplify this analysis. So here we can do this. We are going to set the type of horsepower as int, just in case. And we're going to plot the histogram of horsepower to see how this distribution looks like. This is going to help us analyze in the future. But here we have matplotlib. Remember, we saw that this library for plotting. And we have a histogram plot here, which is this function for horsepower column. And we're going to set labels like horsepower and count for the x and y axis and the title of the plot. This shows us this. For example, here, most of our cars, the bigger group is going to be between 48, which was the minimum, and 103, something like that, right? We have like 1, 2, and 3 groups. So that's what we're going to do. We're going to build 3 bins with equal bandwidth, and for that we use this method called linspace. Here we send the minimum value, the maximum value, and how many cuts or how many dividers we want. If we want 3 bins, we were going to have the first divider, that's going to be the minimum value, the highest divider, that's going to be the maximum value, and 2 in the middle, which will give us 3 bins. So if we execute this, we're going to have these values, 48, 119, 190, and 262. The minimum, the maximum, and 2 in the middle, right? And we're going to define names for the bins for us to make sense here. And we have low, medium, and high horsepower values. Now we have a method called cut, which lets us cut this into the bins. Like this is 150, goes to medium bin, and that's going to classify them in the bins. That way we can know that a horsepower of 111 is a low, it's going to go to the low, right? And like that, useful function, value counts. So for our new column, horsepower bin, we have 153 values in the low bin, 43 cars in the medium bin, and 5 cars in the high bin. And now we can visualize these bins in a histogram plot. If you remember something about statistics, this histogram lets us see the frequency of a value. So for our first bin, we have sort of 153 values that was here, 43 for medium, and a little bit of cars are in the high bin, right? And for now, we're going to save our updated data set. Remember the methods we had for getting the information, from reading the information from a CSV, JSON, Excel, SQL file? Same goes for saving our data set. For our case today, we're going to use CSV files. So we're going to set a path and save to CSV in that path. Now, we have cleaned and we have transformed our data. Now, we have mostly finished our data wrangling part for today, which is cleaning, selecting. Remember, gather, select, and transform the data. So now we can do something with it. We know we have a clean data set. We know we have something that we can analyze now and that we can rely on for creating a model and to find some interesting stuff. So as we're not going to actually create a model today, we're going to do some exploratory data analysis. This lets us do 4 interesting things. First, summarize the main characteristics of the data. So we have a lot of different variables for our cars. So we're going to summarize which one of them are our main characteristics. What of those are important to us? Gain better understanding of the data set. So we get to know what we have, what we're working with, and uncover relationship between variables. This is really interesting. We're going to do something of this today. And extract important variables, which lets us know, for our example, if we want to predict the price, which of these variables is important to us. If, I don't know, the height of the car is important for the price, or maybe the how many doors the car has is important for the price. We don't know yet, but we're going to find out. We are going to get help from Descriptive Statistics for this. Where if you had studied something of this, we have measures of central tendency and measures of dispersion. That is, for example, the mean, the median, the mode, the quartiles as central tendency, which lets us see the frequency of how many times something happens. And the measures of dispersion that lets us say a range, for example, or the standard deviation for a value from our mean, right? And finally, we're going to see some grouping for this purpose. So let's go with our demo. We have descriptive statistics, right? We have a method, really interesting method here in Pandas that's called describe, and gives us all this information in one simple line. This is what I actually love about Python, that we have these kinds of libraries that lets us do all of these calculations with just one line. So we have the count, for example, for everything, we have 201 values. We have the mean for each of the variables. We have the standard deviation, which if you're a data analyst or a data scientist, this is really interesting, really important for us to get. Maximum and minimum values, and the quartiles that mean how it's divided and how our information or data is distributed. Now we have another interesting method. I would like you to remember these methods because we don't have today enough time, but this is really important to get to know. And this is an easy way to get all these values and descriptive statistics variables. Now we can use this info method that gives us a simple summary of our data frame. For each column, how many not known values I have and the type of the column. And we can, for example, do this. Get the count of the value and convert it to a frame. This to frame lets us print it like this. A simple table, a simple visualization table, which, for example, if we want to analyze drive wheels in the cars, for example, front wheel drive, rear wheel drive, and four-wheel drive, different kinds of drive wheels in the car, right? For the ones that love cars. And we have 118 forward, 75 in the rear wheel drive, and just 8 are four-wheel drive. So we want to use this variable here to do grouping, some grouping. So this analysis can be made on the individual groups. And for example, today we're going to see, what do we want to know? The average price per drive wheel type. So we can have a lot of sources, a lot of cars, and we're going to group them in different characteristics, So we have a cool method called unique that gives us the unique values for a column. So for drive wheels, we only have these 3 possible values. Now we can select some relevant columns and assign to a new variable. We can create a new data frame with just these 3 columns. Remember the 2 brackets syntax. And we can calculate the average price for each group. So we're going to use this group by method that lets us calculate the mean for each group in that data frame. That's it. We have the mean price for the rear-wheel drive cars. It's a lot higher than the 4-wheel drive and the front-wheel drive. You see, we have around 9 and 10,000 and 19,000, almost 20,000 for a rear-wheel drive. So here we have our first insight today. Rear-wheel drive cars are much expensive, are a lot more expensive than the other ones. So if you come to me with a car and you say, how much should this car cost? I could ask you, is it rear-wheel drive? Yes, so it's going to be expensive, right? This is something we can now use as information from the data we have. Now, we can also group with more than one variable, drive wheels and body style, for example. We execute the same that before. We have this table, which, for example, 4-wheel drive sedan are more expensive than hatchback cars. So this is interesting to analyze, right? And we can print this as a different kind of table, a pivot table it's called, where we put one variable in the x-axis and another variable in the y-axis for the table. So in the vertical and the horizontal axis, we have that front-wheel drive, sedan, or wagon are the most expensive in the front-wheel drive. See, in the rear-wheel drive, we're going to see that the most expensive are sedans. No, sorry, hardtop cars. So this is now information for us, you see. And now we're going to analyze something really interesting that's called correlation. It's the final thing we're going to analyze today. Interesting stuff. Measure the extent of interdependence between variables. So how much one variable affects another one. So we're going to use something called Pearson correlation. That's a statistical method to calculate this correlation. Pandas lets us do this as a default with just this core function. We can set different kinds of correlation mathematical methods, but the default is Pearson, the most used one also. So if we use this, we're going to have the Pearson correlation for each variable against the other variables. So if you see here, our diagonal here has 1 for everything, because symboling depends on symboling always, and length always going to be affected by length, right? Both are really strongly correlated because they are the same. But for example, in our today's case, we want to see the price, how is it affected by every other variable. So for Pearson correlation, we have this standard that if the Pearson correlation value is 1, it means we have a total positive linear correlation, and means that they affect each other in a positive way, a positive slope line, if you want to see it like that. If we have a 0 or near 0, we have no linear correlation. It doesn't affect each other. And we have a -1, we have total negative correlation. This is the minimum value, the maximum value, and this means nothing to us, right? So for the price, we're going to see that, for example, we have the price here. This is a -0.08. This is a really small correlation, negative correlation. So symboling doesn't affect price, or not much, right? But for example, here we have a 0.87. So what is this? Engine size really affects the price of a car. So with this in mind, we're going to analyze a little bit more about each of the most affecting columns. That can be width, height, for example, see, the engine size, and some other that we can get from this table, which we gather with the core function. Remember, now we have something else interesting in statistics called the p-value, and this represents the probability that the correlation between these two variables is statistically significant. So analyzing all the data, how probable is that this conclusion we got from the correlation, from the Pearson correlation, that is or not affecting a variable, how much, how probable is this to be real? So if we have a p-value for less than 0.001, we know that the correlation is significant and we have strong evidence. So we're going to execute this due to the time we have today. So we use this from SciPy library. Remember, we were talking about it for more advanced math stuff. So when we import it, takes a little bit of time here. We can execute this Pearson R that gives us the Pearson coefficient and the p-value. So, for example, for the wheelbase, the Pearson correlation coefficient is 0.58 with a p-value of 8 for elevated to -20, which is a lot less than 0.001. So the conclusion here is that we have a statistically significant correlation, but the linear relationship is not too strong. We have 0.5, just half. So executing the same for everything, we have 0.8, for example, for horsepower, which means it actually affects the price. For the length, we have 0.69. It's a moderately strong relationship. For width, we have 0.75, quite strong. For the weight, we have 0.83. It actually affects it. The engine size, 0.87, we saw that. The bore, 0.54, moderate. For the efficiency of the car, city miles per gallon, remember, 0.68, it does. And for highway miles per gallon, it also have a moderately strong correlation. So this lets us get to this conclusion. We have some important variables to analyze if we want to create a model. We have the length, width, curb weight, engine size, horsepower, the efficiency, which comes in the city and highway miles per gallon, the wheelbase, and the bore. So it's mostly efficiency, engine, and size of the car. You see that? So this is what matters the most for us to predict the price of a car. And also one categorical values that we have, the drive wheels. Remember that the rear-wheel drive cars were a lot more expensive than the others. So this is really important for us as a conclusion today, because this is going to help us build a model that is reliable. Because if I use a variable that's not useful to predict the price, and I use those variables to predict the price, our result is not going to be reliable, right? This whole pre-processing step is really important to build a successful and reliable model. Well, now what? Now what? Next step, try to build a model for predicting stuff from our data. This is going to be analyzed in the next time. And feel free to ask some questions today. We're going to go to that step, but feel free to read more about this because it's really interesting to learn how to do interesting stuff with raw data, which doesn't really mean anything for us. This comes from an IBM course, Analyzing Data with Python. Really recommend that. Entry-level course, but really interesting. And thank you very much, guys.
Great, Adrian. It was a really amazing speech. I think we got one question. I don't know if you are able to see the question in the chat. It's from Emmanuel Medrano. You are mute, by the way, Adrian.
Yeah, I'm just reading the question, sorry. How accurate is to fill not assigned values with the mean, right? That's the question, right?
Yep, correct.
Give me a minute. Okay, so this is one strategy that we can use. It depends as data analysts or data scientists on what we're going to do. So in some columns, it's going to be accurate. It's going to be useful. For example, I don't know, in our case, the horsepower won't be a really good example of accurately setting up the mean. Remember that we had really a separate, if we go back to see the distribution graph or plot here, we have like 3 different groups actually here, right? A lot of cars are here, some cars here, and a little bit of cars are here. So the mean is most probably going to be here around the 120. That was 122, remember? So it's going to be, probably it's going to be okay, but it's probable that the car, the mean value for the car that when it's likely going to have a value between, that's what the scientists or data before just can use the mean. That's not always the case. So if we have something,
Well, guys, I think we lost Adrian. So technical problems. We are in a live event, so let's see if we can reconnect. So let's have some patience. So thank you very much for sending your questions. I think Adrian is back. Hi, Adrian.
see. Okay. Sorry, guys. I think I got dropped out of the call.
Yeah, I think we got some problems. Yeah, technical problems. Don't worry. This is a live event, so that those kind of things happened. So yeah, I don't know if you can continue with your answer. I think we are running out of time, and there is still one question more. And so please, if you can retake and finish the answer.
Okay, sorry about that, guys. So that's the thing. The data scientist needs to analyze what kind of data we have. We might need to see something like this plot to see if the mean is going to be useful or if not. If not, maybe the strategy is just to drop the values, right? If I have a car with the horsepower, which I don't have the value for the horsepower, and I know that the horsepower might be really distributed, and don't have like a normal distribution, maybe the mean is not the best strategy, and I just have to get rid of that car for my analysis.
Okay. Thank you, Adrian. I got another question. When we have missing data, it is advisable to both scenarios, one estimated that data according to the most probably data, and the other getting rid of it and comparing both results at the end. How do we know we are not introducing noise to the data? That's a really good question.
Yeah, that's a really good question. Thank you, Juan Luis, I think. So
Yeah, one
mostly the
research.
same as the last question. So this is where the human brain comes into play, because a computer won't be able to get to decide that, right? That's where we need to analyze it. We need to see which variable are we going to use as the last case. If we have a not normal distribution for our variable, most likely the mean is not going to be a good strategy. The drop might be a better strategy. And because, as you said, that's right. If I don't have a normal distribution and I set you mean the normal distribution, remember the Gaussian, I don't remember the name, the Gaussian bell. Remember, for some of you that might have seen this in a statistics class, if you don't have a normal distribution where most of the values are in the mean or near the mean, maybe the mean is not a good strategy. That's most likely that the actual value that we're replacing is going to be noise, because most likely it's going to be like here, but I'm replacing it with something in the middle, and that's not the most frequent thing that happens. Also, the most frequent in continuous numerical values might not be the best solution. So we need to think about something on this. There's a lot of research going in on this for statistics, mostly mathematic research, to see what we can do when we don't have a value. For now, what I can say is, if you don't have a normal distribution, if you have some kind of variable that might not affect a lot to the actual result we want, if it's not an important variable for us, in this case, for example, some of the variables that are not in our final list, we might be better just dropping the value, right, for now. So otherwise, we might need to do a more advanced mathematical analysis for this. You're right. Otherwise, it's going to be mostly noise that we're adding to the model. Thank you for the question.
Thank you, Juan Luis. Thank you very much for your question. And I think that's all. Thank you very much, guys, for joining us this Lunch and Learn. And remember to subscribe to our channel and look for our social network in Instagram and Twitter. And thank you very much for joining us. I will see you next month. Thank you, Adrian. It was an amazing speech. So
thank you, Winston. Thank you very much. And thank you guys for joining us today.